All right. Today we're going to be talking about HTTP host header attacks. So without any further dilly-dallying, let's just jump into it. The host header is exactly what it sounds like. It's this, header right here called host that determines the host or the, like basically the IP address in most cases where your request is going to go. In this case, it's a GET request for the blog endpoint to vulnerable.com, which is the host. Now, this is typically, or this is pretty much always a mandatory header, and it just specifies the domain name that the client's trying to access. Now, in some cases, requests are forwarded from one host to another, so the host might change before it reaches like the intended backend destination. Imagine if you're hosting, like you have on your home network, you have one, port that you've port forwarded, like port 80 or something, and you on your internal network have like your media sharing server and maybe like I don't know, like a game server so you and your buddies can play Counter-Strike, whatever. You might use the, some front end like load balancer or routing machine or some kind of routing logic to determine where those incoming requests go to. And so this is something that the host header might be used for. Now, how do I describe it? This is like, there's multiple reasons that's important. First is, even in that example, right? Like you only have so many IP addresses, so it's not uncommon for cloud service providers and like virtual hosting platforms to use this kind of strategy to split things up and also make it easier to just route requests. It also helps you route requests, like I kind of explained, through other hosts. In each of these cases, like the host header is relied on to determine the intended recipient to a request. So like, imagine that you're sending like a letter to an apartment building, right? Like you couldn't just send a letter to an apartment building and expect it to get to the right person. Even if you put their name on it, you'd want to put like the apartment number so it gets put in their specific mailbox. Things like that. That's basically what this host header is for, as it pertains to like navigating it through intermediary hosts in larger networks. So, I think it's pretty straightforward. But without, dwelling on that too much, let's just kind of talk about what an attack would look like. So some websites, especially like, I'm describing, like a lot of servers will trust this host header and won't validate it, which in some cases might be okay. But the thing is, if we can manipulate how the server behaves, we could cause, at the very least, unintended functionality, and at the most, quite a few like damning, pretty high impact stuff, depending obviously on the implementation. So if we're injecting any value in the host header, we'd call that like host header injection. And this example I've got here is kind of to draw reference to how a lot of off-the-shelf like web applications, so like Shopify, WordPress, like a Hugo blog, things like that. If you have some like off-the-shelf web application that you just plug and play with, typically you would configure the domain name in a config file. And there might be links like this one here that use the like part of the host header to determine, in this case, a link to a support page. And the reason that could be harmful, right, is because as long as you have a proxy, which, through our web app, videos we've talked about, like that's basically the bread and butter of any of these web attacks. So everybody's got a proxy. The host header is something we can manipulate as we're sending these requests, basically most of the time. And these vulnerabilities are typically around because developers or, sysadmins or whatever, they don't know that the host header is, or, they don't think that the user header is user controllable. And that makes sense, right? When you're developing an application, you don't think that your users are going to be putting all your requests through a fancy proxy, software and trying to play with it and trying to poke at it. You just think that they're going to be doing the, normal use case. And, you gotta, to have a secure application, you got to think a little bit outside the box. So, if we're able to overwrite this host header, there's a few different ways that you can, kind of take advantage of this. Obviously, like if you can inject this, you might see cache poisoning, you might see business logic issues, depending on, what's being done, server-side request forgery, things of that nature. And the way that that might work is, first you want to identify and do some like light exploitation. So for example, arbitrary host headers would be something like, it's not quite this first one, but just add some junk to the end of your host header and see if something weird starts going on, see if the application behaves strangely or if it doesn't change at all. Flawed validation is basically using, if you have like a strange header that's just a bunch of garbage and that gets rejected, um, you might have like a website that uses a parser on the host header to emit like, let's say like a port number. So if you're running something on port 80, the parser might be trying to get rid of that, or maybe it, takes account of it and puts it somewhere, who knows? But, you might be able to do something like this where you put your malicious, payload, whatever, after this, the colon to say that it's like a port number. For ambiguous requests, you could do something like this where you declare the actual host in the, endpoint, but you say that the host is your host, or, something like that. And the reason you might want to say it's your host is like, let's say that that you can get a request sent at least into the load balancer, but then you want to access some other host that should be an internal only resource. That would be like a routing based server side request forgery, because the front end server isn't supposed to send you to that internal only resource, but it does because you changed this host header. And then like similar headers, so you've got like X forwarded host, X forwarded by, X forwarded for. There's a lot of headers like that are treated by a lot of web technologies similar to the host parameter, or my bad, host header. And so you might be able to take advantage of which one of these will take precedence by the application, or if there's differences in how the front end and the back end, servers handle these different headers being included. So those are a few ways you might be able to identify this. And then there's a few like other exploits that I kind of want to touch on, and obviously there's more than I'm covering here. Like one example would be like if there's a forgot password functionality, if you can control some attribute of that link, or if the like password reset link that's emailed to you is determined in some way by the host header, and you submit a request to reset a password with the host header that's for your domain or your IP address, then if somebody tries to reset their password, you're going to see it get sent to you, assuming you can serve that to a victim. And then web cache poisoning, this is a cooler example, but let's say you can change your host name and it gets reflected on the site. This by itself, right, isn't really like that terrible, because in theory, it's only affecting me. So, if I can change this, maybe if I own this Gabe CTF domain, it'll reach out to my IP address for tracking.js. But, I need to manipulate the host header, and we can't get a victim to manipulate their host header. However, if we can manipulate some like web cache poisoning stuff in conjunction with host header injection that's meaningful in some way, then, in this case here, if we can get this response cached, then it will serve this, JavaScript, or this JavaScript right here to any users that visit that cached response, and then they would be loading this tracking.js from our IP address, which we could, turn into like a simple cookie stealer or something like that. But you probably get the idea. There's host header injection and host header attacks, from what I can tell, seem to be like a lot of these like more like higher level web attacks. They're things that you can chain with other attacks really well, and they synergize a lot with certain types. So like you might see routing based server side request forgery. So if there's an intermediary service between a front end request and some like back end service, if that host header isn't validated correctly, then we could probably get some kind of request to go to the wrong host if it's not doing proper stuff. There's also like a connection state attacks, which are basically like there's lots of sites that reuse connections for like the same client to make request response cycles. So if you're able to send one legitimate and one request with a weird host, you might get it routed to the correct host for one of them, or at least for the first part, and then maybe more of the maybe that second request that you send in that single connection state or over that single connection will be interpreted differently. You also might find that like the request line itself might have issues. You might be able to just use like the @ character to use like an upstream URL to try and log in. Sometimes you can get stuff out of that, but those are just a handful of things you could go through. The next thing we'll do is we'll jump into a hack the box machine called Forgot that has us exploit a forgot password functionality using host header injection or host header attacks. And then we'll come back here and talk about prevention. All right, so I've pulled up the forgot machine from Hack the Box, and we've got the IP address here. I'm just going to duplicate this tab once because I think we'll need a couple. And we're met with a login screen, and we can try, like, and obviously, like, we don't have an account, that's not going to work. And there's a few things we can do. Forgot password, fitting the name of the machine makes sense to try and give a go. And if I just try, like, Gabe, you can see, invalid username. So already you can use this to determine if there is a valid username that we can, you can fuzz this parameter in a bunch of requests and use this to figure out if, you could use it to kind of like backwards make a username list. We could try root. I don't think that's going to be a user on here. Goodness, this takes a while. We could try like admin maybe. Will that work? Admin password can't be reset. Okay, so we know that we can at least validate proper ones. And this machine, if you just do something kind of CTF-y, but this is also good. We go back to the login page. If you view the page source, you'll see, a bunch of default stuff. And then you see a comment here. And this is an important note. If you're a developer, remove your comments, especially if it's going to be visible on the production environment, right? Like, even if it's going to be in like a beta testing environment, try to just remove your comments from any front-end code that's going to be visible by end users. Anyway, Q1 release by Robert Dev 1090. So I'm assuming that that's an actual username. We'll give it a second to go here because this thing seems to like being slow, very slow. Goodness. Is this thing broken? Hold up. Let me... Oh, wow. That is being slow. Okay, now it looks like we've got it. I've reset the machine. Hopefully this works. Let me turn on... Or actually, we still got this saved in burp. Let me just paste the IP address in here. See if that works. The cookie isn't valid, so probably not. Let me turn on intercept. Or maybe, okay, cool. We've actually got this working. So if we are to use that username that we got a second ago, oh, did I miss it already? Or is it not on this page? Oh, goodness. What was it, like Robert-dev something? Let me do... Is it really not on here? I thought we saw it on here. It must be on the regular login page. Forward. Let's grab that username again. We go Robert-dev. Oh, whenever it's ready. Okay, you can see that it says the password link was sent to the user's inbox. Please use this link to reset our password. So, we don't have a valid account to use to verify how this works. The difference is, let me just spin up a terminal real quick. And we're just going to make an HTTP server. And what I'm going to do is grab that password reset, send it to my repeater. And I'm going to replace this with RIP, which is 10.10.14.195. If you were doing this in a different environment, you might use your burp collaborator. We're using community edition, so our collaborator is not going to work. We'll go ahead and hit on that send. It'll take a second. It looks like it's sent. It says password link has been sent to the user inbox. Don't see anything on our HTTP server just yet. But I don't know if we should expect to see something like that. Let me double check. Maybe we need to do like multiple. I don't have like very detailed notes on this, but let's see. Robert Dev 10.10.14.195. That is us. Let's try doing like an X. Let's try doing something like that, maybe. Oh, spelling error. Oh, okay. I got impatient. So you can see all the ones that got queued up here. Um, I guess it's assumed for this machine that the victim user is clicking on these emails that are being sent for the password reset link. And you can see that they're doing, it's getting sent to our IP address. So the reset link is being created with this host header. And that's why after a short period of time, when the victim user clicks on that reset link in their inbox, it's being sent to our IP address. And of course, we know that as long as the reset link they clicked is made with this, it's not going to the actual endpoint. So we're going to send one more. We're going to wait for that to come in, and then we're just going to use that information to forge to reset their password for them. So I guess we'll give it a minute here while we wait for this. Let's see. Right now it's 1812. Goodness. I guess he clicks it a bunch of times. All right, well, we'll take the most recent one. Let's grab reset everything from slash to here. Go ahead and do copy. I still have my proxy on. Intercept is on. We go to, I think it would be, it doesn't really matter, does it? We'll just do this. We'll go to reset. Looks like it works. Maybe I have to hit save, forward, success. Okay, I'll hit save again, forward, success. Yeah, invalid token, makes sense. We already reset it. Let's try to log in. And what was his username? Robert Dev. And if we just forward these, you can see that we gained access to this person's account. So worked out fine. This is just abusing a password reset functionality to take advantage of, it's taking advantage of a password reset functionality that uses the host header to generate the password reset link, because we can manipulate that host header, and because we can figure out which, we found a valid username, we were able to solve that no problem. So just a quick example. Let's go ahead and jump back and talk about prevention. All right, so as far as prevention goes, the most straightforward approach is to avoid using the host header altogether if you can, or at least in your server-side code, obviously, because you need to use the host header. But in all your server-side code, you don't really need it. Most of the time, you can use a relative URL, other than ones that are set by the host header. And then, if for some reason you can't do that, try protecting absolute URLs. I don't know why it says headers there, but protecting absolute URLs. So require a current domain to be specified in like a config file that you use, and only use that value instead of the host header. And that's kind of solves most of your problem. If you can't do that, if you really need to use a host header for something important on the server side, then, at least make sure that you're validating it with a whitelist and like redirects or rejecting all requests that don't meet those criteria. And if you have to do that, make sure that you're whitelisting which domains are permitted, because you don't want like a malicious subdomain to be an issue, or you don't want some error in your parsing to cause problems. So, whitelist as best you can, and configure, if you're using like a load balancer, to actually whitelist properly. You could also, or you're going to want to avoid using like internal only virtual hosts. So like, let's say in the example I made up in the beginning where I talked about, how I have like a forward-facing server and I let my buddies play Counter-Strike and look at my media server, I might have like a private server on there that's only accessible by local host. But again, if you can change your host and that's all I use, you can manipulate your host header to pretend like your local host and then access other functionality. So those are some examples of, how you can go about preventing this if you need to use those host headers for some kind of logic. But that's all we got for today. I'll catch you in the next one.